Good morning, or good afternoon, or good evening, depending on where you are. This is the March online meetup for Rancher, titled Automating K3s Cluster Upgrades. My name is Tom Corway. I'm the Director of Product Marketing at Rancher. I'm standing in for my colleague Adrian Goins, who usually does this. So I'm the newbie to these meetups. And I'm joined today by Bill Maxwell, who's a regular. He's our Director of Product Management. And also Jacob Blaine Kristen, who's a Principal Software Engineer at Rancher. So we will be your hosts, but there's a couple of people also in the background. There's Matthew Shear and also Craig Gillick, who are helping to deal with your questions, and also will be answering any technical questions if they need to. So first things first, this is a meetup, not a webinar. It's kind of informal. We do things a bit differently here at Rancher. It tends to work pretty well. We're not going to be spending an hour just pitching product. This is really designed to provide you with insight into the context in which Rancher exists as much as anything. So we do encourage lots and lots of questions and user feedback, and we will be pausing during the course of the webinar to answer your questions. So just fire them into the questions panel if you have them. And also, there's some rules. Let me do those first of all. This is quite a relaxed sort of environment. We don't really keep to the clock. We probably go over time. We will try and answer all of the questions during that time. And really, there are no silly questions. So go ahead and ask them. If you're confused, just ask a question. We'll try and clarify. There's going to be a demo. In fact, there's probably going to be a few demos. And, we'll need to keep our fingers crossed for the demo gods. Things could go wrong. It's a live demo. So if that does happen, please be patient. This meetup's also being recorded, and we will be posting it to our YouTube channel, which is really a great place to go if you're using Rancher or E or K3s or any of the other things that we do. I'd also recommend looking at Adrian Goins' YouTube channel as well. He does a lot of videos on Rancher. So Goins is spelled G-O-I-N-S. His first name is Adrian. And it's always entertaining to go and see the stuff that he puts together. Right, so join the conversation on Twitter. So hashtag Rancher Meetup. If you're on Twitter, we encourage you to, and if you hear something interesting, or if you want to reach out to some of the other people on this meetup, go ahead, take a picture of yourself, stick it up on Twitter, and let us know that you're part of this meetup. We also have a Slack channel for Rancher users, which, as you can see, it's got almost 16,000 users registered so far. It's hugely popular. It's a great place to go if you have any Rancher questions, anything really. There are people who work for Rancher Labs, but also very active in the community, who would love to meet you and help you out. And the Rancher Slack is the place to go, and that's at slack.rancher.io. Right, the agenda. So it's going to be pretty packed. This meetup. I'm going to do just a few more minutes. I'll try and keep my spiel to as minimum as possible, and then I'm going to be handing over to Bill. He's going to be talking about the next version of Rancher, which is 2.4, which is coming out at the end of this month, and some of the features in it, including the enhanced K3s support, and also a new capability called System Upgrade Controller. Then Bill will be handing over to Jason rather than Jacken. So there's a spelling mistake there. Jason, he'll be doing the demo, and then we'll have the full team helping with the Q&A after that. So that's the plan. So fingers crossed. So quickly, just a bit of context, and I'll keep this down to a minimum. It's about as salesy as we're going to get today, but it's really useful to understand kind of the Rancher vision around Kubernetes and how to make the most of your Kubernetes environment. So this is we talk about this image which we call the cube cake, and it comes in three components. In order to be successful with Kubernetes, first of all, you need to use a certified Kubernetes distribution that's applicable, the most applicable, most appropriate for your use case, and also the location of where you're running your Kubernetes cluster, whether it's on-prem, in the cloud, a combination of the two, whether it's on your laptop as a developer, or whether you're using you're deploying clusters to the thick or the thin edge, the branch, and the sort of more extreme edge. Sitting on top of your Kubernetes distributions, you should have a centralized management console, which should do three things mainly: help you out with cluster operations and make that easier to deal with, enforce consistent security policy, and sort of help you integrate your Kubernetes environment with the rest of your infrastructure. And also, it should give you familiar tools that you're used to using, and services that are easily accessible and integrated into the tool, so that it's just really, really easy to adopt. And then lastly, a slightly sort of newer aspect to this sort of cube cake is the DevOps automation that sits on top, providing you with a secure application deployment environment, slightly prescriptive, that allows you to deploy your applications quickly and easily and securely. This is the way that we recommend you do that. From a certified Kubernetes distribution perspective, we've got RKE in there, which is our distribution for on-prem and hybrid, and also K3s, which is a lightweight version of Kubernetes that we launched about this time last year. It's been hugely popular. It's ideal for development laptops, or running Kubernetes in branch and edge locations on low resource hardware, and often ARM hardware as well. But Rancher supports any certified Kubernetes distribution, and perhaps the most important from a cloud perspective are EKS, AKS, and GKE. So we are that single pane of glass for all of the clusters that you're running, whatever Kubernetes distribution that they run, and Rancher sits on top. And those three sort of requirements that I articulated in the previous slide, from a simplified cluster operations perspective, of course, we tick that box. There's integrated monitoring and alerting, version management, centralized auditing, and so forth. And it's just a really pleasant place to be, both from a UI perspective, but also the CLI perspective. We've got a really strong story around our authentication support, particularly around Active Directory, which lots of people use, but also Open LDAP and other services like Okta. And people like us a lot for our policy management capabilities, particularly our really strong RBAC model. And sitting on top of that, we've done a great job, I think, and of course I would say this, but I think we've done a great job of integrating the tools that you're already using: Prometheus, Grafana, Istio, which is still sort of rocket science to many. We make the consumption of Istio much more straightforward in Rancher. And sitting on top of that, we have a newish project which is currently in beta called Rio. And that's the beginnings of our sort of our micro-PaaS, our secure application deployment environment, which is slightly prescriptive, but it won't take over your cluster, but allows you to easy access to load balancing and routing and auto scaling, canary deployments, and that sort of thing. So this is the Rancher recipe for production quality Kubernetes at scale. And I think that's me done. And I will spend hopefully very little time handing over the reins to Bill. So let's see if we can get this working. There we are. There we go, Bill. Are you there, Bill?
And I was on mute. Yep, there we go.
Cool. All right, I'll go on mute now.
All right, so first things first, we're going to do a quick Rancher 2.4 update. We're working really hard on Rancher 2.4 right now and should be shipping soon. The key features to look at are basically around, one of the main is scale. We've done a lot of work to reduce the memory and CPU consumption and increase the number of clusters that you can manage. This is going to be really, really beneficial as we look to adding, as we adding additional clusters to service the edge use cases. So if you're looking at building out clusters in your remote, branches or your remote offices, the more clusters, the better. For what we're moving for, and really preparing for being able to manage a large number of clusters and deploying applications to that. So we're laying a lot of groundwork and scaling up Rancher in 2.4. For those of you that are just existing, have a lot of clusters and notice that the boxes are running hot, you should see that some of the resources come back to you. And so we're pretty excited about those improvements that we've made, and I think as users you'll really enjoy them as well. We've redone the upgrade procedure for RKE clusters, and so we're adding as non-disruptive upgrades as possible. So you'll be able to keep your Kubernetes API up and available during the upgrade process, and we're giving you all the mechanisms you would need to keep traffic running to your applications during the upgrade process as well. So you'll be able to pick the number of nodes, drain, core, and move workloads throughout the upgrade process, and it'll be dramatically improved over where we were. The other key feature that we did a meetup on in January was the CIS benchmark scans. Those will be coming, and you'll be able to schedule and automate those scans and have the updates, an alert as your configuration drifts. This is really completing the story that we've been building out over the last year, and so we've been, building out cluster templates, providing hardening guides, and now the last bit is now you can observe and report and adjust. And so you'll be able to round out and continuously scan your clusters, and ensuring that you've hit the CIS benchmarks. Other features that are coming, we're going to have experimental support for OPA through Gatekeeper. This will allow you to set up policies within the cluster for enforcing things like registries or labels or any other policies that you want to enforce on your Kubernetes objects, that they're created a certain way. And so that'll be experimental. The catalog will gain v3 support for Helm. And so you'll be able to designate a catalog specifically for v3 catalog entries. You'll be able to customize your global roles and assign groups to those global roles, which is new and should make administrating in Rancher much, much simpler. We're adding support for new versions of SUSE Linux and Oracle Linux. Rancher HA will now be supported on top of a K3s distribution, and with that installed, you can offload your etcd management to, there's no etcd required. You can move to a SQL solution, either managed or you can run your own if you've got in-house expertise on running MySQL. And then we're also previewing the new Rancher UI, which will bring a lot of a refresh and a lot of visibility around Kubernetes, more of a Kubernetes native view, focused on namespaces and all of the objects. And so you'll be able to edit CRDs and create objects that you haven't been able to do in the current UI. The new format allows a lot more raw editing of objects, but still has niceties bubbled up and simplified user experience that we've presented in current versions. We think you'll really like it, and so it's going to be a preview, and you can tell us what you think kind of in the 2.4 series, see if we're going down the right direction. Projects will of course still be available, but that won't be the primary navigation mechanism. So you can still manage projects, and you'll still be able to assign group membership and manage a collection of namespaces as a single entity, but they're not, again, not as part of the top level navigation. So we think there'll be less friction as users coming from kube control straight to a UI. It'll translate a little bit more simply. All right, but to the point of today's meetup is K3s Cluster Management. This is a new feature coming into Rancher, and so in 2.3 we introduced the ability to import the clusters, and you can see them and manage them, deploy applications to them. And so the next step in the managing of K3s clusters is the ability to upgrade them. And so in the new UI, we've gone ahead and we've added the ability to have select the next version. There's a new update service that'll let you know when there's upgrades available. And the model had to change for us in this because as we were building this out, with Rancher, we've typically assumed that you're running in a data center or a cloud-like environment where you have a consistent set of networking, reliable storage. Basically, cloud native where things can fail, but for the most part, there's a certain set of services that are considered mostly reliable. But moving towards K3's edge use cases, that's no longer the assumption that can no longer be assumed. You've got when we're talking to customers now, we're talking about these clusters might come and go from network connectivity for a period of days or weeks, or they might have low bandwidth 3G connections back to the data center. And so in that model, we really had to rethink the information and who's controlling and actually orchestrating the different bits. And so that led us down a path of looking at the way we've done it today. Rancher is in this data center model. We're actually orchestrating the upgrade of every node individually, and we're able to keep on top of what the current state of the world is, and we rely on the network links and an always-on connection. And so what we've needed to do in the future is we needed to assume that the connection between Rancher and the cluster is no longer reliable, that we're not necessarily going to know the exact state at any given time. And so we've needed a controller in the cluster that is local, that will then be responsible for being able to handle all of the upgrades and facilitating it in a safe, reliable way, still providing a lot of flexibility in how things are going to come online and offline with minimal updates back to the Rancher server. And so what we're going to look at today is our path at that and the technology that'll be coming in 2.4 for upgrading Rancher, and that is the system upgrade controller. And to demo that, we'll be handing it off to Jacob. And I'm handing it off to Jacob. You got it, Jacob? I think you might be on mute.
I was on mute. Okay, so the system upgrade controller was something that I began working on as part of K3OS, which is a K3s adjacent project, but soon we realized that it was going to apply to more than just that particular system. It could actually apply generally, and so we started targeting K3s, and it's sort of how I became involved with it. But let's talk about what is this thing and what does it do? And it's a lot of syllables, but it's not a super complicated thing. And let me say that in general, I'm not a fan of reading slides that I wrote to people that are looking at my slides, but I think this is a good introductory paragraph that we can then jump off into more detail, right? So the system upgrade controller, it manages plans by selecting nodes to run upgrade jobs on, and jobs are targeted specifically for a single node, and that's it. A plan defines which nodes are eligible for upgrade by specifying a label selector, right? So that means a plan is not just a one and done. A plan is an outstanding intent to mutate nodes that are a member of your cluster. When the job is run to completion, then the controller will label the node as per the plan that it ran the job for. And all that means is that's the controller's way of saying, okay, I don't need to run this particular plan for this node again, unless the criteria change for that. And that gets me into sort of more of the underlying details for what that would be. And so you can see, as per the diagram here, there are secrets on this. And that is because as initially developed, the controller was really concerned with the concept of an optional upgrade channel, and then an override, which is a version that then gets lifted and munged, because that could be a semver with metadata on it, and that gets munged into a Docker tag, right? And that's the reason that that exists, is so that we can have enough information to pull down an image and then use that image to mutate the node. And so now I'm getting into a bit more detail, and we might want to see what a plan looks like. And so for purposes of this demo, and this is going to be the later demo here, I have put together a plan with some corresponding secrets to help show the various different things that we could do with the plan, right? So the secret here is just, hey, I've got a Linux version, and I've got a script that I want to run, excuse me. And that script is to upgrade that kernel and incur a reboot. And so what you'll notice here is that, well, if this runs multiple times, isn't it just going to reboot every time? And the answer is no, because once it's upgraded, then the run reboot required will not be there, and then the system will effectively be done. This is important because sometimes when you're applying a job, a reboot is in a race with the controller to, the controller wants to mark it as done, but a reboot in the middle of a pod in the job effectively marks that pod as an unknown status. And so what happens is the reboot happens, and then the job gets applied again when the system comes up, but then it gets to the same end, and then it realizes it doesn't need to reboot, and it moves on with things. And the controller marks it as done, and everything's good and happy. But how does the controller actually, well, how does a plan, as understood by the controller, actually describe what needs to be done? As you can imagine, you don't want to just apply this to all of your nodes. You probably want to have, you know, some sort of thing that denotes or connotes your batch size. In this case, we've called it concurrency, but as currently implemented, it also doubles as maximum unavailable nodes in the system. And the reason that that's important is because you may want to perform a drain and do other things. And of course, if you're rotating masters, you want to keep some of them that are able to talk to the external database, such that you've got a zero downtime upgrade. But backing up a little bit, so in this case, for Bionic nodes, what I've decided is to reuse the label right here, plan.upgrade.catalog.io/Bionic. That's the label based on the name of the plan that the controller will place on a node, and it uses a SHA-224 some value, and that's only meaningful really to the controller. But if you change it, it will, you know, if you ended up editing that label on a node, you would find that your plan was reapplied. But if your plan is defined in such an idempotent way, meaning that it, with the same inputs, it gets to the same results, then you wouldn't really incur any change whatsoever, other than a temporary drain if you happen to have that configured. And so I'll get to the drain in just a moment, but we've also got a service account, and that's because as I left off, I realized I left this off on a slide, but the job is run as what I like to say, quote unquote, as a very privileged pod in these jobs, and that is they've got capsys boot, obviously, so they can perform reboots, and they also mount in the host, PID, IPC, and network namespaces. And this is to make sure that reboots are achievable under various different methods. If you can imagine, calling reboot from systemd requires a network, as well as, I think, PID and IPC. But if you're doing it on something like K3s, I only need PID and IPC, and I can chroot into the host and do my stuff. Oh, I keep dropping hints for stuff later on. Getting back to secrets that we talked about. This is a way of referencing the secret that was defined in the manifest further up by name, because they're different types. I can reuse the name, and so that's cool. And I've got just like a little comment here to say, yeah, the path is optional. By default, secrets will be dropped on this particular path based on the name. But because I want to, oh, light just fell down. Interesting. Because I want to chroot into the host system, which is something that I haven't mentioned. The system upgrade controller bind mounts in the host's root directory as /host into this pod, into the containers in this pod. And because I want to chroot into the host and still have access to that secret, I am adding that prefix to it. Hope that makes sense. And I realize that I'm kind of telegraphing a whole lot, but I can describe a plan a little bit later on, and you'll see, or describe a pod that gets generated a little bit later, and you can see the various different mounts that are happening because there's some environment variables, some downward API access stuff. I also mentioned a channel. So in this case, I just sort of threw together a fictitious channel URL. And the idea here would be that very much like a GitHub releases /latest link, you would hit this and then it would give you an HTTP 302 that would redirect you to some URI, and with the last element of the path being equivalent to a semver tag and or container tag. If it's a semver tag, we do some very rudimentary munging, which is changing a plus sign to a minus sign. And because that works for K3s, that works for the only tag that has metadata that we've been working with so far. And that allows us to translate that into a Docker tag. Now, if you have a channel, both a channel and a version defined, the version is treated as an override, and so the channel never gets pulled. And this version is then just, again, taken as an image tag. And you can see, so let me jump down to the upgrade container. We've got like an upgrade container spec, which is very, very, very truncated, very rudimentary compared to the full-fledged container spec you would see in a pod. But you do have the image command and args elements, which work exactly the way they do when you're defining containers in a regular pod. Unfortunately, that's all we've got. We've sort of taken the liberty of applying some opinions to the solution, and that means that we're dropping environment variables and some bind mounts in, as I mentioned before. Now, so we've seen the upgrade, but the upgrade definition, but if you need to do something before anything else happens, before even a drain happens, you've got the option of defining that in a prepare container. And currently that requires a full reference to the image. This does not get appended with the version here, as this one does, as the upgrade image does. And what that does is allow you to wait for certain conditions, or maybe you're logging into some content server and pulling down the content you're going to need and placing it somewhere on the host. Or in the case of K3s, maybe it means you're waiting on, as a worker plan, you're waiting on the master plan to finish before you move on to your drain. And the way that we make that work is the prepare container, if specified, is the first init container. And then the next container is cordon or drain. You can say cordon true, and then you're going to get the unscheduled bit set on your node, and then it's going to move on to the upgrade container. Or if drain is specified, cordon is ignored because cordon is going to happen anyway. And you've got what I like to show here is the default way of defining how we're invoking kubectl, and we're doing that in a container, which is it's a kubectl on top of Scratch, and that's it. And two things I like to call out here are that delete local data and ignore daemon sets are both set to true, which isn't the default for kubectl, but to do anything really meaningful in a cluster, you kind of need to be set to true. And so we did that by default. You can set them to false if you want them to be false, but that's not how it is at the moment. And then I covered upgrade container. So that is what an example would look like for Bionic. Let's get into the rest of the demo.
Yeah, just real quick, now might be a good time before you transition. We do have a few questions.
Okay.
First one is, so what we're looking, can we explain a little bit, like right now, what we're looking at is the plan, right? And that the
Mhm.
plan is, from a workflow perspective, how does that relate to the controller, or just real quick, high level, how does that?
Right. So when the controller starts up, it registers the plan custom resource definition, and then it starts listening for them in the namespace that the controller is running in.
Gotcha.
When the controller sees a plan, it looks for its node selector and says, okay, do I have any nodes that I can apply this plan to? If so, sort of per version, there's a unique ordering of the number of nodes that qualify on the selector that it will then go through and attempt to apply. It'll create jobs upon which will apply the plan that is defined, that is encapsulated in the combination of the prepare, drain, and upgrade containers. And a minimal plan just has an upgrade container. And the batch size of the number of jobs you'll get will be equivalent to the concurrency.
Okay, cool. And then will the upgrade mechanisms be able to support air gap installs? Will this run in an air gap?
So an air gap is actually one of the reasons why I designed this to use containers, is because with a relatively recent-ish fix applied to K3s, you can define your own repositories, image repositories or registries, which means that provided you've got all of your air-gapped images running within a network accessible by the node, then yes, you will be able to quote unquote pull your images and apply them as you would expect normally. And so, and then what happens is it's just a matter of currying your images from the internet at large to your air-gapped installation.
Okay.
If I can tack onto that one just real briefly, this is Craig Jellick. With the integration into Rancher, where we support K3s upgrades via this mechanism, we'll do the work of currying the images for you for air gap. So just as you do today for a Rancher-based air gap installation, you have to run a script to pull and push the images. The images relevant to upgrading K3s will be part of that package.
Great. Okay. Yep, we can keep going for now.
All right, so getting closer to the meat of the demo, we've got a multi-plan definition here for upgrading a K3s cluster. We've got a master plan, which sounds ominous, with a concurrency of 1. And we want to target the latest and greatest 1.17.3 tag that K3s was released with. And we only want to apply that to nodes that are the instance type K3s. That's like a nice selector. If you happen to be running this in a heterogeneous deployment, you might want to say, you know what, if it happens to have a K3OS tag or label rather, maybe don't apply it to there because it's got its own mechanism for upgrading. But with node selectors, you've sort of got this ability to completely define exactly which nodes are eligible for application of a plan and hence mutation. And so one thing that we're doing here, the real trick here is we've got this K3s upgrade, which is like a gate label that I haven't applied yet to my cluster when we go and look at it, but this one has been applied, right? So for the master plan, we want that to only apply to master nodes. And as you'll see, the worker plan is exactly the same, except for 2 bits. And that is the master role selector is inversed, reversed. And there's a prepare container, which says, hey, run the exact same container that's going to be run for the upgrade, but override the default command to run this prepare and refer to, strangely enough, the plan over here. And what that's doing is it's saying, hey, master plan, is your version the same as mine? Yes. Okay. Are there any nodes that are currently being applied to? Okay, I'm going to wait. And then it loops and waits until the list of applying nodes is 0, and then the worker plan will happen, and we'll be able to actually see that via the kubectl output. So having shown the plan, I want to give people an opportunity to ask questions, but if there are none, I'm ready to jump into the first bit of the demo, which would be showing this via CLI.
Yeah, one that's come up a couple times is sort of, I mean, as you talked about dependencies and sort of the init, I think in the pre, is there an after update stage or like a post reboot hook?
So no, again, the best way of applying a post reboot hook is to make sure that you reboot in your pod and not, if your imperative invocation of reboot incurs a reboot in the background of the system, then your job is going to be marked as successful and nothing will happen. But on a systemd system like the Ubuntu nodes that I'm running on, a reboot in pod causes the job to not finish successfully. And what that means is then when the node comes back up again, it runs the job again. But because the end result of most of the work of the job is where it wanted it to be anyway, then it realizes it doesn't need to reboot again. And so what happens is, this is a long way of saying that there is no post reboot hook at the moment, because this controller is essentially not aware of what's going on in the pods themselves. It just schedules the jobs, right? And so a post reboot hook is strictly up to you to make sure to do or not do correctly in sort of an idempotent manner, AKA, did I mutate state? Yes, okay, reboot. And then the next time you run, oh, I don't need to mutate state anymore, therefore I don't need to reboot. So that, in effect, you're in charge of your own post reboot hooks.
Right, and the user, as part of the OS booting backup, has, I mean, depending on their environment, they could have cloud init scripts available, or other startup scripts that could run as part of the OS coming back online and getting added back into the cluster.
Right, one could imagine drop-ins that the upgrade controller actually, places on the host to be picked up at reboot. Because maybe they're a one-shot on first boot, a la cron job. I forget what the format is, but cron can say, okay, has it just booted? I'm going to run these executions. Similar method can be done.
Cool. Thanks.
Anything else?
No, let's see the demo.
Okay. All right, so I've got a number of clusters running, and you can see I've got a watch of my K3s nodes running on Ubuntu 18.04 systems. And I happen to have the caffeine's coming back to me. My plan pulled up just so people could see it if they wanted to. And so I believe all of my nodes have all the labels they need, except for this one last bit. And forgive me for doing kubectl and the likely of typos in a demo. I realize I've got my good keyboard, so that should be minimized. But this is where I live, and so this is how this is how I run my demos. K3s. Hopefully my typing is not too loud. Equals. I think as long as that isn't false or disabled, that should be good enough. And so what will happen when I run, a couple of seconds after I run this, is we should see that one of the nodes, specifically the master node, is going to become at status ready and unschedulable. And then after a bit, we'll see it, the version will bump and it will be not ready, unschedulable. And then those two things will go away and we'll see it move on to the workers. That's as it works as it should. So here we go. Watch system. So we can see that immediately, somehow multiple workers were running. Oh, and so right now my kubectl invocation to the master is gone, and that's because I coordinated it quickly and bounced it, and now it should come up with a new version quite soon. And so you see the worker jobs were waiting in their first init container. And you see now that the version for the master node has been updated. And then when it comes up, the job, yep, okay, now the controller has marked that thing as schedulable, and we've moved on to the next container on the worker nodes. I'm not sure why there are two going. Did I have a concurrency of two set on that? I thought I had it left as one, but it might be two. Oh, it's two, yeah. And we see quickly the workers are having their version updated. You see the scheduling is temporarily disabled because of the cordon/train. And then all of the jobs have completed, and we now have upgraded nodes. So first part of the demo done. Any questions?
No, we didn't have any new ones come in that were there.
So here's the thing that I did promise, which was describing a pod, so you can see sort of more of the detail that's put in there for containers. So let's do. And we'll just grab one of these here. One of the workers, yes. Oops.
Something happening.
Have we lost him?
Yeah,
Jacob?
we might.
Sorry. Okay. Hello. My network
Hey.
flipped out a bit.
Yeah, you're back.
Can
You're back.
you hear?
Yep, you're back.
Okay. I'm not sure what's going on. I haven't moved. Let's see.
It's the demo gods, mate. That's
Yeah.
always happens.
So, well, we'll take a break here. So what we just saw in this last demo is using the system upgrade controller in its raw form, and this is the system upgrade controller is an open source project. All the sources available on Rancher, and we're going to see our next demo. Craig Jellick will be running, and he's going to show what the integration in Rancher will look like. From that standpoint, it's a much simpler interface, and so there's two things we're showing here. One is the raw technology, which we're pretty excited about, and how to interact with it directly. And it's very flexible framework, and so you're free to download it and try it out and use it however you want to experiment with it and play with it. When it comes to integrating into Rancher, we're taking a conservative approach and solving initial problem of upgrading first, and so it'll really be used in that scope. But we have a lot of we have high hopes for moving it to our next. We have plans of integrating it and using this technology to help facilitate additional operations. So later on, I think we'll see a demo of what it could look like to use the controller to do OS updates or patching along those lines. So for now, I will shift over to Craig. You ready, Craig?
Sorry about that. Not sure what happened to my network.
Yeah, it's all right. But yeah, if you need to fix something, now is a good time while Craig's demoing. But yeah, so Craig, I'm just looking at questions real quick. So is K3s going to replace RKE, Rancher OS, etc.? K3s is a fully featured Kubernetes distro. It definitely has a strong use case due to its simplified operations model in the edge, but it's also a very capable data center distribution. And so we're looking at different ways of pulling that into product, and our thinking is still ongoing as to how that roadmap will end up shaping up. But it is a key piece of technology, and we have a lot of different use cases that that we think has of opportunity for us to explore with it. So you'll see a lot more things that we're doing with it over the year. Is RKE upgrade supported? So again, it's a controller. At this point, we're primarily focused on its K3s use case. You know, in looking at what it would do for RKE, that's something that we could look into in the future. But right now, RKE has a different path in 2.4 for sure. Yeah. Okay, I think that's good for now. Craig, I'll give it to you.
Great. Can you hear me okay and see my screen?
Yes and yes.
All right, awesome. Okay, so I thought that was a really good demo by Jacob to kind of show the flexibility and power of the framework. And I think Bill did a good job of sort of explaining how we're going to sort of leverage that in Rancher. And that's what I want to show here, is sort of that streamlined integration into Rancher with K3s clusters. The first thing I want to call out is sort of what the approach we've taken in 2.4.0 is to bring forward an MVP and then add features to that MVP. You know, as time, as the 2.4 release cycle moves forward and as we get more feedback. So this MVP is going to allow you to import K3s clusters. Rancher will then recognize those clusters as actual K3s clusters. And then by recognizing them as K3s clusters will allow you to do things like see the arguments that each K3s node was started with, upgrade the K3s version. And then beyond that sort of MVP, you'll be able to even change the configuration of the master nodes and any worker nodes in your K3s cluster. So the first thing I want to show super quickly here is you can see I have 3 K3s clusters here, the providers showing that they are in fact K3s. Even my local cluster, which Rancher is running on top of, is a K3s cluster itself. So if I jump into this first cluster, the thing that I want to show here is how you can see the arguments that this cluster was launched with. So if we jump down here, oh, did I jump to the wrong one? Oh, I jumped to the wrong one. All right, we'll switch to this one. So if I go to the edit cluster screen, you can see a couple interesting things. One, this is a K3s centric view of the edit cluster screen. You can see the options here. You can see that you have 117.3 available for an upgrade. This version, it looks a little strange because this is actually a master build of K3s. The reason I'm using a master build in this cluster is to show this functionality down here, which is we're bubbling up the arguments that this cluster was started with so that you can see them and view them in Rancher, you know exactly how this cluster is configured. Like I said, beyond MVP, this is just read-only right now. Beyond MVP, you'll actually be able to edit these configuration parameters and push those down to your cluster. But we're just starting with the ability to change the K3s version. There's 2 primary ways right now you can configure a K3s cluster: command line arguments, and then environment variables as well. So we display both of those. And up here, you could just see simple things like the concurrency that Jacob had mentioned when he was talking about plans. So the other aspect of this I want to show is this is my node screen. So these are all the nodes in the cluster. Once again, you can see the K3s version. And what we were just looking at was the master node, but you can see we did the same thing for the worker nodes as well. So we've added a K3s information section down here, and you can see exactly how each node in your cluster was launched. And what I did here was I added just an explicit external IP so that you could see something actually interesting. So yeah, so this gives you a good bit of visibility into your K3s clusters and how they're configured, and paves the way for being able to push down configurations to nodes to change them as you want to introduce like a new secret provider or a new kubelet argument, for example.
And Craig, one little bit, maybe you're getting to it, is the token is empty, and that's for a reason.
Right, yes. So this token is actually a sensitive parameter. So we basically blacklist case arguments that we know are sensitive and shouldn't be exposed up and out of the cluster itself. And one small UX change we'll make to this is, we'll have, this is just currently empty. One thing will change, that'll show, it'll be literally the word redacted or something like that, so that there's a missing argument here. Cool, so that is the power of exposing these arguments. I'm going to jump back to the cluster list screen here and show an actual upgrade. So you can see this cluster is 1.16.7. We're going to upgrade this cluster to 1.17.3. And again, dropping down into here, we can see that I have 1.17.3 available. And this will work similar to how RKE is currently working, which is once we release a new version of K3s and then vet it, independently, vet it sort of with its Rancher integration, we'll be able to push out that new version, push out the fact that that new version of K3s is available dynamically. So without upgrading a Rancher, you'll be able to see, oh, 1.18.2 is available, and you'll be able to upgrade your clusters to that version. So I select 1.17.3 there. I'm going to leave concurrency at 1 and 1. And just calling out here that you can't see the arguments on this cluster because this version of K3s doesn't support the bubbling up of those configuration parameters. So I will go ahead and click save here and jump over to the nodes page. And you can actually see one other thing that we're still working on is sort of the conveying of status. You saw it jump to updating and then left. We're gonna kind of work out the details with that, so it's more clear that it's sort of upgrading at this time. But you can already see in the background, what we've done is we've deployed the system upgrade controller to the K3s cluster. We've deployed a job that the controller picked up, and it's actually executing that job now. You can see that the master node was cordoned, and it'll be moving through its upgrade process as we go. So that happened because I split my screen to kind of just be able to watch the nodes from kubectl below, but it was unable to connect because this is a single master node cluster, a single server node cluster, and so the API is literally not available. But so now we see it is available. You could see the master node went first and upgraded to 1.17.3. And what we'll see next is that the worker nodes, having waited for the control plane to be completed, will now upgrade to 1.17.3 as well. So we see that moving along. Basically, the containers being pulled to the worker node, and the pod is the job pod is being executed to perform the actual upgrade. This ends up taking just a couple minutes to complete. But once it does complete, we'll see it kind of come through on both the nodes we're watching below and in the UI above. There we go. Just saw it bump up to 1.17.3 there. Uh-oh, plague is not healthy. That's never, plague errors are the bane of people's operators' existence. Okay, I went away and recovered, and just like that, we have a 1.17.3 cluster. Yeah, so that is pretty straightforward, but that is the demo in a nutshell. I was going to import, I think I'll just quickly show you, just to give you a quick rundown, the way you import a K3s cluster is no different than it's been. Test cluster 3. It's still the same workflow here. So we generate an import command, we can copy that and come over here to my third cluster. Change this to my alias. And we see this cluster coming up. So there's test cluster 3. The import is actually pretty quick here. We'll see it sort of showing up and hooking into the API in just a minute. Okay. Yeah, you see it coming up. And then finally, we have one small bug where the provider doesn't change to K3s until you do a page refresh, but that will, yeah. So we see test cluster 3 has been recognized as a K3s cluster and we're ready to go. This is a 1.16.3. You can see we actually have 2 upgrades available for it. We could jump to 1.16.7 or 1.17.3. I think that's sort of the plan moving forward, right? Is to, for all the versions of Kubernetes that we support, we'll supply the latest patch version, or you can go to, the next minor version. That's my demo. Any questions come up while I was demoing, Bill?
I think you got it, because we had one about the import process, which sounds like we're keeping the same and there's nothing special that has to be done.
Yeah, I will make a comment on that, which is I think longer term, as we move to more sort of fleet style operations, being able to manage thousands of clusters, I think what we discussed and what we think makes sense is the ability to sort of, without having to pre-create. So the flow right now is create a cluster and then import it, right? So it's kind of, it's a multi-step process. I think we'll build out in the future a way to import clusters that just basically you could import, using the same command, you can import, 1,000 clusters. So we just have to work out the authentication and authorization around that. But I think it'd be a useful enhancement for scaling up to fleet size loads.
Yeah. That makes sense. And that addresses another question of how to auto import lots and lots of clusters. And so
right,
that's basically, there's two elements to kind of where some of this is, where we're looking to go with some of this. And part of it is fleet and managing the application and then onboarding the edge scale type of computing, where within this view you'll have this idea of like a cluster grouping, if you will, and joining possibly those groups. And so you can create groups and manage them as pools of clusters, and looking at some of the fleet stuff. And so and then deploy applications of those, and depending on how you do operations, basically we're managing, the way we're looking at fleet is managing just Kubernetes objects. And so this upgrade controller ties into that, in that this is all being driven from a native Kubernetes controller, which has custom resources that can be updated and managed through the Kubernetes API. So we're not adding anything special, but any other integration, when we look at fleet, we'll be able to, you'll be able to execute things against it. But this is all lining up together, sort of native Kubernetes objects that you'll be able to tie together in a cohesive way. And so this is in 2.4, we're laying a lot of groundwork, and that's what you're seeing here is being able to do the import and upgrade. It's still sort of in our the way we were doing it, but we are doing some forward looking as to continuing to improve that at scale experience.
Right, and not to get too buzzwordy, but what we really see we're doing is like laying the foundation for GitOps-based workflows for managing everything from your clusters all the way down to the workloads running in those clusters.
Mm-hmm. Cool. Yeah. Also, I mean, just to call it out sort of explicitly here, the K3s provisioning bit is something we're not currently doing in Rancher, and we're still evaluating whether it makes sense for us to do so. To actually like provision the way similar to the way we do RKE clusters. That's something we're looking at and evaluating over time. But for now, definitely being able to manage and configure them is a primary focus for us right now.
So are there any more questions? Because I did promise a look at the a job description so people could see what the pods and containers look like, what kind of things they're getting.
Yeah, and then you've also got one demo of something that we're looking to do possibly incorporate in future versions of Rancher that you could experiment with in the raw controller at this point, but not a part of Rancher, but something we're excited about and think is really cool. So yeah, let me hand over presenter to you.
I think Craig will have to do that.
No,
Or did you hand it over?
Did you get the request?
I'm not seeing a request, no. There it
How about
goes.
now?
All right, so as promised, before my network died, a look at the job that's generated for a particular plan. So again, this was for a worker upgrade apply. And let's just go through the init container. So here's the prepare container. It's, you can see it's got its state housekeeping, but what I'm looking to show is there are some environment variables that you get sort of for free. So if you're scripting or doing whatever, you can make some reasonable decisions. Like one thing that a subordinate plan should do if it's waiting for a different plan to finish is it should check to see that its version matches the other one. Or is semantically behind it, right? Because if you're upgrading Kubernetes nodes, you don't want the masters, you want the API server versions to be behind what its clients that are going to be talking to it are going to be running. You can also see the host root gets mounted there. There's run system upgrade pod, that's for the pod info to get dropped, and then there's also the location for the service account. I don't do that gets done automatically. Let's see, and then that was the drain container, and the prepare container, the drain container, and the upgrade container, they all get the same mounts, but I believe the upgrade container actually gets capsys boot, which the other ones do not currently. If that's causing your upgrade process a problem, please submit an issue. We'll take a look at it. Any other questions about the detail here? And so here's the volume definitions, right? So the host root is picked up and mounted in the containers and the pod info with the download API stuff. You can even see the labels and annotations if for some reason you need that information. Yeah. And that's it for that. Now, if we want to, I'll give people a chance to ask questions, but the next demo is, let's say you're just running Kubernetes, RKE, K3s, Kubernetes, doesn't matter, whatever. You're running on Ubuntu 1804 LTS because you're responsible. You don't want to get the latest and greatest and break things. But you running these on VMs that are maybe a little pet-like, or maybe they're bare metal machines, and you have to upgrade in place because downtime just for whatever reason isn't acceptable, can't be scheduled for the moment. And so what I've got here is a cluster set up in the exact same way as in the first demo, except for I am going to run that Bionic plan that I showed, right? So, and what this does, and if you remember, I can page back to it. What this does is it incurs kernel upgrade, because as you can see from the, so let's take a look here, right? The kernel upgrade is 1060 and running in AWS, and that's the only thing that's going to be upgraded. And if it doesn't upgrade, a reboot happens. As you can see, from the latest Ubuntu AMI, everything's running 1057 versions of the kernel, the 415 series kernel. And so let me double check that my labels are good. I'm sorry for flipping around on you guys. I'm a cut and paste fanatic. All right, so I just need to make sure that label exists and doesn't have a magic value of disabled. So nodes. I like enabled. And what we should see soon is that one of those nodes, hopefully not the master because that'll suck for the demo, one of those nodes is going to get marked as unschedulable. And then after a few minutes, let's see, let's do a watch. Oh, there we go. Okay, so it looks like one of the workers, perfect. And so what's going to happen here, and this unfortunately takes a couple minutes to reboot, but we're going to do an apt-get update. We're going to upgrade the kernel to that thing on a pinned version, and you'll see when that worker comes up, which is 5.132, you'll see that its kernel version will be 1060. And so the whole point of this is to show that the system upgrade controller is truly a general purpose node mutation agent, or at least it helps you schedule jobs that become those agents for you. And it's a Kubernetes way of approaching your configuration management needs, Kubernetes native way of approaching your configuration management needs. Because maybe, and I'll thank Bill earlier for a conversation that we had. You know, the outside-in approach to configuration management can work, but it can be brittle. Whereas if you're running your node mutations inside out, as opposed to outside in, you've got a lot more rich information that you can act upon and make reasonable decisions. Because maybe, you know what, you can decide in an automated way that upgrade didn't work, it's timed out, I am going to bring that node back in because I need it. These are the sort of things that you can do with Kubernetes. It's very, very powerful. Any questions? Bill, any other comments?
No, nothing's come in at the moment, but you know, just again to reemphasize what's like, just sort of what you were, to reinforce what you were just saying. You know, this Kubernetes, as it becomes more and more key and core to the data center, it becomes an operating model in and of itself. And so, you know, this technology, you know, is able to extend, and then, you know, the same tool that is able to abstract your infrastructure management away from your application is now also, and is in charge of that, is now able to, you know, safely move your applications and move your workloads around while it's managing this infrastructure, which is a really neat and interesting concept that we're having a lot of fun exploring. So, and I think, you know, being able to, everybody's got this problem, you know, having to be able to patch their OSs, you know, either through AMI updates, or, you know, base image updates or kernel patching. You know, you have this regular set of security patching and hygiene that everyone's got to go through at least, you know, once a month, once a quarter time frame. And so as our clusters multiply in numbers and, you know, the number of nodes under management come into play, we really end up in the situation where, you know, this becomes a very time-consuming task. And, you know, what we've heard is when you have to automate it externally and say, you know, kube control, drain, coordinate, apply, that loop and that cycle and the monitoring of it from other tools, you know, it's been challenging. So this is something we're definitely interested in helping with and looking at. And so this is some forward-looking and future-looking, you know, use cases that we're playing with today.
So one more thing that I wanted to point out was I mentioned that a reboot will make dump a job into an unknown state, which is what happened with 132, and then it got run again. And the controller will, by default, and this is configurable at a controller level of granularity, there's a default back-off limit of 2. So it'll attempt to run your job up to 2 more times before it says, you know what, that job's done and it's not successful. As you can see, we've upgraded a kernel, and we've probably upgraded a second kernel, but it takes about a minute or 2 for that node to come up and re-talk back to the master. and then that job will run again. We'll see that show up, and what will happen is you'll see the ready show up first, and then when the job is done, you'll see scheduling disabled. That will go away, which is kind of neat. And if there's no other questions, that's it for me. I'm content to just sort of sit here and let it run to the end and then be done.
Great. All right, while we're doing that, we do have questions that aren't necessarily related to the demo. So we have a couple more slides to sort of wrap up while that runs. So Tom, I'll hand it back to you and you can wrap it up, and then we'll stay on to answer any additional questions.
Yeah, that sounds good. I've only got a couple of quick slides. Right, can you see my screen?
Yes.
Just a reminder on resource. Really, the Rancher website does contain lots and lots of documentation. And having been around the block a few times and worked for companies where the documentation is fairly rubbish, that's not the case here. It's really high quality documentation, all accessible on rancher.com. For those of you who want sort of started with Rancher, there's an excellent quick start guide which you can get to easily from the on the main menu. And just quickly a sort of reminder of the different products and projects that Rancher are involved with. Of course, everything we do is fully open source, but we distinguish between products, which are the technologies that we encourage people to use in production environments, and the projects, the open source projects, where we really sort of where all the innovation that we try and foster actually comes from. So the idea being that things start off as a project, we get people engaged in developing it both inside the company and outside. We test it, we get feedback from people, and then it matures, and over time it either becomes part of our product portfolio, or capabilities within those projects are folded into Rancher. So you're probably familiar with RKE. It's been around a while. We talked about it earlier on. It's the CNCF certified Kubernetes distribution that we recommend for on-prem and hybrid cloud. And then of course K3s, which we've been talking about a great deal today. We touched on Rio. K3OS is also, it's been around now for about a year, and with the intention of making low resource computing operations for low resource computing much easier. And the other one I think that's worth just pointing out is Longhorn. That's of all the projects that we do, that's the one that we've given over to the CNCF really to look after. Of course, we're heavily involved in its development, and we are looking forward to some pretty big announcements around Longhorn later on this year. So we're excited about that. And that's really it, Bill, from me. So do you have any last questions that you want to tackle?
Yeah, I think we have a few. So for those, we'll answer the questions if you've got one outstanding. And for those of you who have to drop, thanks. And the video recording will be available. Just going back kind of at the beginning.
Hey, Bill, while you're looking through this, I just wanted to point out real quick, just to be clear, K3s is also a CNCF certified Kubernetes distribution. So it's fully conformant, it passes the CNCF certification, and is up there in the list too. So just wanted to make that clear.
Great.
Yeah, no, I think I should change the wording. I did mention that earlier on when I was talking about the KubeCape. You're right.
Okay. Yeah. Cool.
So Rancher 2.4 HA install, will it be able to be installed via Helm 3? I believe we've updated even the Rancher 2.3 docs to be able to use the Helm 3 CLI. They simplify by not requiring tiller. So yes, that will continue to be supported. Upgrades from Rancher 2.3 to 2.4, will be fully supported in the new features. One thing to call out is if you, there's no migration to a K3s based install. It would be net new. So for anyone starting out with Rancher, it has the option to pick either going with RKE or the K3 based install. And they both will be supported.
Bill, could I comment on that?
You may.
So just if you're not terribly familiar with K3s, the real cool thing there is you can choose different data store backends. So it's not just etcd, right? And what we really see as a great way of operationalizing Rancher itself is you can run it in, something like Amazon backed by RDS, and then you don't have to worry about managing your own etcd cluster. It's just you can use any supported SQL style database, and it really makes sort of deploying and managing Rancher much easier.
Yep. With the new Rancher UI, it would be nice to support some kind of network policy visualizations. So the nice thing about the Rancher UI, and when we do the 2.4 meetup to walk through the new features, we'll definitely take a look at this. But the new UI actually shows all of the Kubernetes objects. And so whether we've built a first class native UI integration for it or not, you can still get to it from the UI without having to drop down to kube control. And so, at a minimum, you'll be able to see objects in their YAML form, and if there's an open API spec, you'll see which fields are available to you to help you fill that out in the text editor. We think you'll really like it, and so it provides a lot of flexibility in being able to address just UI that hasn't been made available in the current implementation, but we think you'll have a lot more flexibility, and you'll be able to use anything that any Kubernetes object that gets created or operator or controller that gets deployed and has custom resource types. Rancher won't have to create new UI for you to use it. You'll be able to get to it from the Rancher UI, and so that'll be really powerful. We discussed that. We discussed. Yeah. So if someone's, are there some example YAMLs and plans, Jacob, that a user who wants to, start experimenting with the system upgrade controller outside of Rancher could look at and use as guidance? Will the link
yes. So I just finished, let's see, last week I finished some demos for Ubuntu, developing a different plan, but a similar flavor to this one, for upgrading Ubuntu nodes, right? And I've got an outstanding ask for CentOS, which I haven't worked on yet. But these are in the examples directory in the system upgrade controller project on GitHub.
Cool.
And I will be updating the Ubuntu one with my kernel upgrade later today, possibly tomorrow.
Cool.
Bill, if I could, I think this question is basically saying the example YAMLs we had were demonstrating how to upgrade the host OS. But then the demo that I did was the K3s version. And the question is the idea that these would be two different concerns or approaches. And so what we were trying to do there was the integration in Rancher, where we just upgrade the K3s version, that's MVP of how to upgrade your cluster. And that's what we wanted to basically control and get out there first from a officially supported Rancher mindset. But the system upgrade controller as a whole is much more flexible, and that's what we see sort of the future of this being, is the ability to upgrade everything down to the OS. So you could do those things yourself. I would say kernel upgrades, OS upgrades, using the system upgrade controller directly. Those are sort of more for the community to try out, experiment with, give us feedback on, and we'll work on that feedback and figure out how to integrate it into the broader Rancher ecosystem later.
Yep. Does anyone know, with this approach, make something like cured unnecessary? I believe that's a Weaveworks project.
Yeah, so I was looking at that a bit, and I think there's a lot of overlap between the two projects. I could also see a case to be made for how they could be complementary. But fundamentally, I think when you look at cured, what it doesn't solve is getting the upgrade media onto the host, right? So it's kind of assuming something else has done that and then has requested a reboot of the node, and cured can handle that reboot in a Kubernetes aware way so that it knows sort of it's only doing one node at a time. It also looks for Prometheus alerts, and if there are some, it won't do the reboot. So it's sort of more intelligent on the reboot side, but doesn't have the capability of doing the actual installation of whatever thing you need to upgrade. So I think if you're using cured, you're already solving the install and upgrade problem some other way. This could be an alternative solution to that, but you might miss out on some of the more advanced features of scheduling the reboots that cured has.
Cool, thanks.
Mm-hmm.
I'm not sure I fully get this one, but is it possible to import the existing Helm into Rancher? Right now, when I import a K3s cluster into Rancher, the Helm, which is inside Rancher, is different from the Helm used in the actual cluster. I think I'm taking this to mean the Rancher catalog and the distinction between catalog and Helm, native Helm experience. And the way that those are built are two separate concerns. They're different and deliberately so. And so at this point, no, there's no plans to make Helm releases show up as apps in the Rancher UI today. Does anyone else have a different take on that, or is that?
That is I interpreted it the same way. The question and your answer, Son, I think, yep.
Yep. When will we release Longhorn? Longhorn is working towards GA, and it's currently targeted the first half of the year. So stay tuned for that later. Announcements around that. Cool. I think that's all the questions that we've got.
There's just another one that's just popped up.
Oh.
Is it possible to move a Rancher created cluster from one Rancher server to another?
It is currently no, not possible to do that today.
Okay. All right. So does that bring us to a conclusion for this meetup, Bill?
It does.
Okay. All right. Well, only to say thank you so much for joining us. It's been a pleasure to have you, and we look forward to seeing you again. Do follow us on Twitter and the various other sort of social media states that we're on. LinkedIn's another good one. And you know, thanks again, and we look forward to seeing you soon. Bye.